Yeah, so hello, welcome. We're going to go back kind of to the topic of the first talk, but kind of zoom out a little bit. So if you were really digging into the Yang models and things that were on the slides earlier, you can probably go to sleep now. For those of you who had no idea what was going on, this talk is for you. This concept of the API is the new CLI. I think if you're paying attention to new trends in networking, you've probably heard some variation of this statement. And I kind of want to unpack it a little bit and look at what that means, right? So really starting simplistically, we're really talking about two different interfaces, right? The command line interface, which is set up specifically for people to interact with machines, and the application programming interface, which is set up specifically for programs to talk to programs. And I think that's important as we work through this. And really, when we're talking about APIs and networking anyway, there's kind of three that I think you need to pay attention to. So there's netconf, there's REST, and there's RESTconf. So we'll look at those each here really quickly. Netconf is the network configuration protocol. It's defined in RFC 6241. And as it says in the RFC, it provides mechanisms to install, manipulate, and delete the configuration of network devices. So this is what we typically call CRUD, right? Create, read, update, and delete. So doing configuration actions against devices. It does this through a remote procedure call. So basically there's a client-server interaction where the client is the script or application or controller that's going to be sending RPCs, requests, to the server, which is, in this case, a router or a switch or something like that. It's transport protocol agnostic, but SSH is required to be supported, and that's what's typically used. And then all the data that you're shipping between devices and the scripts or applications you're running are encoded in XML. So that's the basics of how netconf works. A couple things that are interesting there. It does have the idea of a configuration lock. And when you combine that with the two-way communication between the client and server, you end up being able to do atomic changes across the network. What I mean is if a configuration change fails on one device, you can essentially roll back the whole change across all of the devices that you were trying to change, which is pretty handy. Also, it defines this idea of state data, which allows for kind of the other direction of information, where I kind of look at, if you're looking at automation or SDN or any of those things, you're really trying to do two things, right? You're trying to put information into the network by configuration, and you're trying to get information out of the network through telemetry. And the state data defines those kind of events and things that you can pull out, so you can get telemetry-like data from your devices through the same API, which can be either in addition to or in support of configuration changes, right? So again, going back to that atomic change, you can actually verify that the changes were made and had the effect you wanted them to have. So then the next API I want to talk about is, our type of API is REST. So REST stands for Representational State Transfer. It is defined in a PhD dissertation by Roy Thomas Fielding called Architectural Styles in the Design of Network-Based Software Architectures. Just because it's fun to read poetry on stage at NANOG, what is life? It is the flash of a firefly in the night. It is the breath of a buffalo in the wintertime. Is a little shadow which runs across the grass and loses itself in the sunset. So these are actually in the beginning of the paper, if you read it. But I think actually the second quote is actually more interesting, where he talks about the fact that, he says, one day when we have learned the timeless way again, we shall feel the same about our towns. I think this kind of reads into potentially not just city design, but perhaps application design. Maybe we should take a timeless approach and look at that. Maybe that's kind of a side diversion. But that's in the beginning of the paper. The rest of the paper explains, well, basically how REST works, which is essentially just the way the web works. So REST is essentially using HTTP, all the things like get, put, post, delete. Instead of interacting with a website, you're potentially interacting with a router or a switch or a firewall or whatever else. So you can get information in and out. And then when you combine the two, right, so RESTconf is essentially netconf over HTTP. So instead of using SSH, you're now using HTTP. From the RFC 8040, it's an HTTP-based protocol that provides a programmatic interface for accessing data defined in Yang using the data store concepts defined in the network configuration protocol, netconf. So again, it's a RESTful implementation of netconf. A couple of things that are different from or added to, I guess, in RESTconf versus NetConf, is you can actually use JSON instead of XML, which a lot of people find easier to read and fun. It also defines an event stream, which again kind of enhances potentially the telemetry ability. So you can actually subscribe to a stream of event notifications through the API to get constant information from the devices. So kind of a push model versus a pull. So potentially, right, replacing SNMP with an API that you're using for configuration as well as telemetry. Pretty cool. So devices can support NetConf, they can support RESTconf, or they can support both. And a lot do both. So it's not an either or choice necessarily, but definitely something to look at when you're getting new devices. Do they support these protocols? If you want to work down the programmatic interface to your network. So Yang is not an API. It is defined in RFC 7950. It's a data modeling language. So essentially, right, if we put these kind of all together, Yang is the data model, which is the template for formatting your data. Then you can use either NetConf or RESTconf to encode that data with XML or JSON to send it to or receive it from a network device over SSH or HTTP. That's kind of the whole package of what we're talking about with the APIs in network configuration. So the original question was, is the API the new CLI? And I think, as we've hopefully seen, right, APIs are definitely powerful tools. They allow programs to communicate reliably with network devices, and this could be just scripts talking to your devices that you can write yourself. This could be full-on intent-based systems where you have a complete abstraction between you and the network, where you are interacting with some system that is then interacting with the devices through an API. Again, I think back to the very first slide I had, which is this idea that APIs are really for software to talk to software. Whereas CLIs are still there for people to talk to machines. And so, yes, APIs are here to stay, but so is the CLI. So I think in situations where you're doing intense troubleshooting, those kind of things, I think for a long time anyway, maybe not always, but there will still be a CLI there. But I think routine, day-to-day, more and more, you're going to be using an API and some kind of software to interact with your devices rather than directly logging into each machine, especially as we scale. So obviously, those of you who run really big networks are probably already completely doing this. You have been for many years, maybe even just back to like expect scripts and those kind of things. Now there's actually an API to do this. So the answer is no, it's not the new CLI, but yes, it kind of is. I have a YouTube channel with a bunch of videos of talks from NANOG, from Wright, from a bunch of other conferences with a bunch of stuff about automation and how to dig into the details of actually how to implement all of this, if you want, as well as just digging through the archives themselves. With that, we have a couple minutes if anybody has a question. Otherwise, we'll get to the closing. Thank you.